Worksheet video. So we're going to start off with this first problem. It says use partial fraction decomposition to solve the integrals, which really is going to be a theme of all these problems, but let's go ahead and get into it. We have an issue where the bottom is not factored, so we have to manually factor the bottom. We see that 10 as factors of 2 and 7, and that, 2 and 5, and that indeed does add up to 7, so we know we can split that up to be x plus 2, x plus 5 over x plus 14. So that means partial fraction decomposition wise, we'll get a over some x plus 2, and then b over some x plus 5. Then afterwards, we can go ahead and just multiply both sides to get a times the x plus 5 plus b times the x plus 2. We distribute a bit, 5a plus bx plus 2b, and we get that a plus b has to equal 1, and then 5b plus, oh no, sorry, 5b, 5a plus 2b has to equal 14. Well, we know if we make this negative, or we subtract this from this twice, so subtract twice, i.e., I'm going to write like this just so we can make sure we have the notation. So minus an a minus a b minus a 1 minus an a minus a b minus a 1. We'll have 3a on the left-hand side, and then we'll have just 12 on the right-hand side. A must be equal to 4. And then using this guy, if a is 4, then b must be negative 3. So then we can go and plug it in. Should be 4 over x plus 2 minus 3 over x plus 5. This integral can then extend to 4 over x plus 2 minus 3 over x plus 5 dx. The answer then can be 4 times ln of x plus 2 and minus 3 ln of x plus 5. And then plus c. Alright, seems easy enough. Next problem we also have to factor ourselves, so we know 9 has a factor of 3 times 3, which if we add those up, we get 6. So that means we can factor this into x plus 3 times x plus 3, which is really just the same factor repeated twice. Which means we do one factor with one unknown variable with one factor, and then we do the repeated version. Then we multiply both sides to get 5x minus 2 is equal to a times the x plus 3, and then plus b. Because we know that we multiply the denominator, we're just going to get that b. And then, from there, go and distribute the a to get 8x plus 3a plus b. Here we have the luxury of just having a being equal to 5, but then we have to figure out 3a plus b is equal to negative 2. Well, if a is equal to 5, then 15 plus b is equal to negative 2, which means b is negative 17. So if that's the case, then this becomes 5 over x plus 3, and this becomes minus 17 over x plus 3, squared. From here, we replace the variable to be 5 over x plus 3 minus 17 over x plus 3 squared. Dx. I'm going to do this one already. That's going to be 5 ln of x plus 3. And then minus 17 of 1 over x plus 3 squared dx. For this, I'm going to use a substitution. Let u be x plus 3 and du be dx. So that means we have 1 over u squared. And then we have du. This is then equal to u to the power of -1 over -1. That will simplify to 17 and then over u. Then we plug in u back to be 17 over x plus 3. Okay? Then we can write the full answer, which is 5 ln x plus 3 minus 17. No, I'm sorry, plus 17 over x plus 3. Hold on, I kind of wrote that in a really ugly format. Here, I'm just going to scratch this all out. 5 ln x plus 3 plus 17 over x plus 3, and then plus c. It's going to be our final answer. And then the last one has the added difficulty of a quadratic being involved. So we know that we have to split this up. Into 1 with just x minus 1, and then bx plus c over the quadratic x squared plus 1. In that case, 4 is equal to a times x squared plus 1 plus b x plus c times the x minus 1. From here, it should be a squared plus a. From here, we're going to distribute piece by piece, so it's going to be bx squared minus b x, and then plus cx minus c. Okay, so from here, I'm just double checking all my math. Okay. So gathering up all the x squares on the right hand side, we have no x squares on the left hand side, so that's going to be 0. Gathering up all the x's on the left hand side, negative b plus c. On the left hand side, we also don't have any. And then gathering up all the constants, a minus c, we just have the one constant on the left, 4. Okay, so let's go ahead and do some magic to figure this out. I guess I'm going to go ahead and subtract these two. So that way I can get another term with just b and c. But if I have to subtract it, I want to try to make b positive. So I'll do a plus b is equal to 0 minus a plus c minus 4. So I'm subtracting this guy. So I'll get b plus c is equal to -4. And then we combine those two to get 2c is equal to -4, which means c is equal to -2. From here, we can use this guy to get b is equal to -2. And then we can use that guy to get a is equal to 2. So then we can split this up to be 2 over x minus 1 plus, they're both the same thing. I'll start at -2x and then plus, or not plus, minus 2 over x squared plus 1. That lets us rewrite this whole thing as 2x minus 1. I'll go ahead and I think I'll leave it on top. -2x minus 2 over x squared plus 1. From here, what I want to do, which will probably be easier, is split this fraction because hold on, I'm gonna run out of space. Well, for the first guy, I know I can evaluate right away. It's gonna be 2 ln x minus 1. But I'm gonna split up this fraction because there's gonna be one version of it where I'm gonna use u substitution because its derivative appears in the multiplicative product. And then for this one, I'm going to use tangent inverses integral because I know I have the pattern of having something dividing over x squared plus 1. So first this guy, let's see, -2x over x squared plus 1 dx, and plus -2 over x squared plus 1 dx. Over here, I'm just going to do in different color. U is equal to x squared plus 1. Du is then equal to 2x dx. All of that does appear, so we can right away just use that and get negative integral 1 over u du. And we get negative ln of u. And then after plugging in u, we'll get ln of x squared plus 1. Okay, I'm just double checking. Yes. Over here, we recall tangent integral. So the integral here, let me go ahead and just get that from our notes. Give me a moment. So don't forget you have something like this where it's the 1 over 1 plus x squared dx. And the only thing we're doing is we're factoring out the -2, and then the derivative of tangent is also mentioned here as well. So we have simply just -2 tangent inverse of x. And then the last final answer will be, I don't know why I just got the urge to double check. The last final answer is the addition of all these three. So 2 ln x minus 1 minus ln of x squared plus 1 minus 2 tangent inverse of x plus c. And that's going to be our final answer. All right. Let me know if you guys have any questions. And again, I apologize for the weird video of our lecture. And if it doesn't work, again, just let me know I can re-record it. All right. I'll see you on the next one. Bye-bye.